May we have your attention, please?
The technical experts at RSSB learn continually from feedback from the operational bodies that implement the requirements in railway group standards. They also keep up to date with advances in technology that may allow requirements to be met more safely or even more cost effectively. And such is the case with the package of standards published in December 2022. This package looks specifically at issues around electrification, rolling stock, and the interface between the two. 2 railway group standards were revised, 2 new rail industry standards published, and 2 existing guidance notes withdrawn. This standards package contains significant changes and is the second stage of a 2-part approach to updating this group of standards. The previous update was a much more limited change, which was published in 2019. To give us some more detail about this package of electrification standards, what changes will be made, and the benefits they'll deliver, I'm joined today by Mike Tatton, Professional Head of Energy at RSSB, and Darren Fitzgerald, Principal Electrical and Systems Rolling Stock Engineer. Welcome to you both. I'll start, if I may, with Mike. Please, would you introduce yourself and tell us how you came to your current role in the railway?
Thank you. It's quite a long story, so I'll endeavour to be brief. I started my railway career some 45 odd years ago working on traction and rolling stock. But since then, I've spent the bulk of my career in railway electrification in various roles. First of all, working for British Rail, then through the period of privatisation in the 1990s. I worked for a major consultancy, worked on quite a lot of the major electrification projects up to about 2000. And for the last 18 years, I've been with RSSB working on standards.
Thank you very much, Mike, and welcome. Let's get straight into the details. I mentioned 2019 in the introduction, so this package of work has been going on for several years. What is the motivation behind it?
Thank you. And in general, standards can and should always seek to embody learning from experience and new knowledge. So it's an ongoing process of keeping things up to date. And the insights and knowledge can take many forms. We have a process called deviation applications, where if you're applying a standard and a need arises to do meet a requirement in a different way, then there's a deviation process which is gone through, considered by standards committees. So as deviations have been raised against the previous issues of standards, we look at those deviations, see what we can learn from them, and endeavour to build that into the next issue of the standard, which is one of the ways in which we continually try and improve things. In addition, we also have findings and insights from research projects which have explored problems and sought to gain new knowledge. We also look for the latest developments codified in new, revised European and international technical and safety standards. And also, of course, a very important aspect is dialogue with industry partners, such as the invaluable insights provided during the redrafting process, including feedback during the formal industry consultation process, which we carry out as a matter of course when we're updating standards.
Thank you very much, Mike. That description applies across the board for standards in general. What have been the influences that have driven this particular package of work?
There have been a number and quite a varied range of things, such as obviously since the standard was last revised, we've exited the European Union, so consequently our standards now have to reflect this new legal landscape we find ourselves in post-EU exit, through to some kind of rather more local matters. As I've mentioned earlier, one of the challenges we've seen this from deviation applications is the specificities that we see in the United Kingdom, the peculiarities that apply to our particular bit of the European railway landscape that perhaps others don't necessarily have the same challenges. One example of this obviously is the somewhat constrained gauge that was bequeathed to us by our Victorian forebears. Of course, in recent years, we've had a number of high-profile electrification projects in England, Scotland and Wales. Many of these are now complete and delivering significant benefits for the users and their communities. However, I think we'd all acknowledge that the delivery of some of these projects has been particularly challenging, including around the cost of the electrification and also timescale challenges. More recent times, we've also seen greater awareness of the environmental impacts of transport, particularly CO2 emissions and the impacts on local air quality. Of course, all of this is now happening against the backdrop of a financially constrained post-COVID environment. So now more than ever, it's important that standards change to help support projects in their mission to deliver efficient and cost-effective AC electrification.
Thank you very much, Mike. So, who are actually going to be looking at these new standards and making most use of them?
The users of this group of standards, particularly the railway group standards, are project entities, and for typical electrification projects, that's very often a role undertaken by, for example, an infrastructure manager, but it can be other bodies on some occasions. And obviously, from a vehicle's point of view, it's typically the manufacturer of the vehicle. Whilst they may be some of the frontline users, as it were, then these standards are also very relevant to assessment bodies who do the third-party assessment of some of the requirements in various standards. Railway undertakings, obviously, who are operating vehicles ultimately, the electrification suppliers and designers, for example, and of course the rail vehicle manufacturers, designers and owners. So it's a broad portfolio of people who will be interested in this group of standards in the round.
Thank you very much, Mike. That's the people who are going to be implementing the changes to the standards, but who's going to be benefiting more widely? Could you summarize the key changes that we're going to see?
Yes, certainly. From an electrification perspective, the most significant changes are in Railway Group Standard GLRT 1210 Issue 3, which is titled AC Energy Subsystem Its Interface to Rolling Stock. This uses the latest RSSB standards document format comprising the following elements: requirements, which specify what must be done or achieved; rationale, which provides the reason for the requirement; and where relevant, guidance, which contains information to assist the user when implementing the requirements. In this latest revision, we've taken the opportunity to remove overlaps and duplications of those requirements which are addressed elsewhere, retained only those requirements which meet the criteria and latest understanding of the specific characteristics of national technical rules. Consequently, the content of this standard is now much more focused on two main areas. Firstly, requirements at the interface between the energy subsystem and rolling stock, in particular, those requirements which support a rule-based approach to ensuring technical compatibility between new, renewed and upgraded electrification, and those rail vehicles which predate authorization under the interoperability regime. Secondly, requirements which provide specific cases for the GV mainline. These typically exist where there's a need to take into account a country or network-specific aspect or characteristic, where there's a need to differ from one or more of the European target systems, either temporarily or on a more permanent basis. It's perhaps easiest to think of these specific cases as being a bit like a car manufacturer changing aspects of their products to meet an essential need in a particular country. For example, making a right-hand drive version of a vehicle for the UK market, or a particular aspect of national law. In terms of the changes within this railway group standard for new, renewed and upgraded AC electrification, I'll briefly outline a couple of examples, if I may.
Please go ahead.
Thank you. Firstly, minimum contact wire height is an important area for the GB railway. As I've mentioned earlier, the Victorians didn't bequeath us a particularly large gauge railway. In this version of the standard, we've retained a 4165mm contact wire height. However, it's now possible to reduce this to a minimum value of 4040mm if additional mitigation measures in the form of a surge arrestor are provided. The latter change is a good example of where the content of this standard has been evolving over time. The possibility of using surge arrestors to reduce clearances was contained in the guidance to the first edition of this standard, published in 2014. By 2019, Energy Standards Committee had received its first deviation against Issue 1 of this standard, where this technology was being deployed to enable the minimum contact wire height to be reduced below 4165mm to avoid expensive bridge reconstructions. Further deviation applications followed in 2021. In Issue 3, We now see this experience and knowledge being integrated into the latest requirements so that this version of the standard enables the technique to be more readily used in future electrification schemes and allow people to benefit. Another important area associated with electrical clearances, the approach to electrical clearances between live parts and other assets has been refined considerably in this revision. It now focuses on the interface between electrification and rail vehicles. For example, ensuring there is adequate air clearance between the live parts of the contact wire and the closest part of the rail vehicle below it. Separation by an adequate air gap between these two assets manages the risk arising from electrical flashover. This can occur if there is inadequate separation. If it does occur, an arc is struck between the two parts and vast amounts of electrical energy are dissipated in a fraction of a second. Fault current can reach several thousand amps before the protection system cuts off the supply. Consequently, these uncontrolled arcing events can be very damaging. Similarly, we need to ensure adequate clearance exists between the air gap of live parts of the pantograph head and earth parts of adjacent electrification system or other fixed assets. Requirements concerning electrical clearances between live parts of the electrification system and other fixed assets such as overbridges, tunnels and other line-side assets have been removed from this issue of the standard. This is because these interfaces do not directly affect the interoperability of the rail vehicles. In this instance, the industry did not wish to codify these aspects within the new rail industry standard. Consequently, the project entity will now determine appropriate provisions for these interfaces to ensure that the relevant essential requirements in the UK's interoperability regulations are met.
Thank you very much, Mike. That's covered the railway group standard. Could you now tell us a little bit more about the new rail industry standard for energy?
Thank you. Yes, this rail industry standard for AC energy subsystems and its interface rolling stock, RIS 1853ENE, is a new standard. It primarily contains requirements previously in Railway Group Standard GLRT 1210 Issue 2, which do not meet the criteria for national technical rules. However, it only retains those requirements which industry considers need to be within an RSSB published standard. So if I may, I'll give you a couple of examples of what's been retained. One good example is the signage associated with electrification. This includes trackside signs which are provided to inform the drivers on the approach to phase separation sections, also commonly known as neutral sections. Other examples include requirements which specify the dimension to be used for establishing the overhead contact line zone. These dimensions are used in conjunction with requirements in European standards which referenced within the national technical specification notices. The dimensioning of this zone is typically set out at national level. This dimensioning supports requirements for the electrical bonding of accessible metal items at line side and which can be a source of an electric shock risk to a person if a live contact wire or catenary wire breaks and comes into contact with them whilst it's still energized. This is the smaller of the two documents and contains a relatively modest number of requirements.
Mike, thank you very much. That's a fairly long explanation of those two. Could you wrap up what those standards really mean in practice?
Thank you. Yes, I can. In summary, the latest Railway Group Standard and Rail Industry Standard for AC electrification brings a much more focused approach to this aspect of standardisation. This has resulted in an overall reduction in requirements of around 50%. Clearly, this represents a very significant and important change to the standards landscape. Once we've explored the changes to the rolling stock documents, perhaps we can take a look at the overall benefits of these changes.
Mike, thank you very much for summing that up. Now let us turn to Darren Fitzgerald to look at the aspects that affect rolling stock directly. Darren, as with Mike, I'm going to ask you first of all to introduce yourself and tell us how you came to your role in the railway.
Thanks, Ant. Yes, I'm Darren Fitzgerald, Principal Electrical and Systems Rolling Stock Engineer, and I joined the railway in 2005 as a traction and rolling stock apprentice. I've held a few positions in the railway since, mainly with an operator, actually almost all with an operator, until last year, in April 2021, I joined RSSB as Electrical and Systems Rolling Stock Engineer.
Thank you very much, Darren, and welcome to the RSSB podcast. Could you start by giving us a summary of the key changes to the rolling stock, group standard and industry standard?
Absolutely. Thanks, Ant. So in terms of the changes that were made, they were made in broadly the same way as the changes were made to the energy standards. So that's the standards that Mike was discussing. And we looked at deviations similarly and discussed with stakeholders the different needs they might have from the standards and reflected on good practice that's out there, but also quite a focus on removing duplication as well. If there's duplication amongst standards, it's likely at an increased cost to industry and also adds complexity to introducing products to the market, especially for rolling stock. So it was important to us to rationalise those, remove any duplication and make the standard as effective as possible. The two standards for rolling stock, the RGS, which is GMRT 2111 issue 3, and the rail industry standard, which is RIS 2715 RST issue 1, are now available on the RSSB website. They define the interface from the rolling stock to the overhead contact line. And they really provide a more practical, efficient way of applying the requirements in comparison to the previous issue of GMRT 2111.
Darren, thank you very much. Could you give us a couple of examples of what's changed?
One example is vehicle bonding. So this is how the vehicle's bonded to Earth and its compatibility with the energy subsystem and how that works. This was removed as a national technical rule in GMRT 2111 issue 3, and any bonding requirements moved to the rail industry standard instead. Through discussions with our stakeholders, we found that through the application of the NTSNs, which are compulsory via legislation, that this was already something that was covered, although it was quite a complex way of it actually being applied. So instead of repeating the requirements, we've tried to set out clearer guidance to show how bonding should be applied and then give some options in the rail industry standard instead on how this might be done on a route by route basis. Additionally, changing the way that process works gives railway undertakings more freedom in some of the decisions they make, and also removes the requirement to assess bonding as a national technical rule, which is an improvement. Another example is the warning line, often referred to as the cant rail warning line, which is the orange stripe that goes around the top of vehicles. This has had to change due to, as Mike mentioned, the lowering of the overhead contact line, minimum possible wire height. This is now with reference above rail level rather than from the overhead contact line. What this means is it was just a more effective method of applying the warning line, and it means that the overhead contact line height now doesn't matter in terms of applying something to a vehicle. And as wire heights vary across the network, this could be quite complex to get right in many cases. One more example might be automatic dropping devices and overheight devices, which are two different methods of automatically dropping the pantograph. These requirements were previously conflated and mixed up because they're two different functions, but often they're mistaken for one another. So these have now been clearly separated in the standards, and this has resulted in a more coherent flow through the standard as well.
Thank you very much, Darren. Very comprehensive examples. Could you tell us then what are the main benefits for this standards change?
So the entire suite of standards, the two for the energy subsystem and the two for the rolling stock subsystem, give a smaller, simpler and more focused set of requirements, particularly for those which are national technical rules, and improve clarity and ease of application. So, for example, helping standards users to more easily differentiate between a requirement which supports authorization for the energy and vehicle subsystem prior to use, and those which support the establishment of vehicle and route compatibility for a particular use. There's also a reduction in the need for third-party conformity assessments in some areas, and as well as a reduced number and more limited high-cost infrastructure interventions at places such as overbridges and other structures, where electrifying our existing railway, as Mike mentioned, with its historic gauge and space constraints, was sometimes very complicated.
Thank you very much, Darren. Obviously, we always seek to make things more cost effective. So what are the main monetary benefits going to be?
So the main monetary benefits across the 4 of the 7 impact areas which RSSB assesses for standards change, which are legal compliance and assurance, health, safety and security, reliability and operational performance, and design and maintenance. The publication of the 4 standards will provide substantial benefit to industry. So in financial terms, it is estimated that the overall benefit to industry from the standard change will be in excess of £27 million over a 5-year period. And in addition to these benefits, the documents can also help support the efficient and timely delivery of future electrification and rolling stock projects. Therefore, if you were to include all of the wider industry benefits, the potential for overall cost reduction associated with AC electrification in the future is likely to be substantially greater.
Thank you very much, Darren. So these documents were published in December and they're in the RSSB standards catalogue, but when do they actually enter into force?
The railway group standards and the rail industry standards the rail industry standards are into force straight away, but the rail group standards enter into force on the 4th of March 2023.
Thank you very much, Darren, and thank you very much, Mike, for your input on the energy standards. There is more information available on these standards on the RSSB website. The Standards Quarterly Briefing webinar, which was recorded in December 22, has a short piece on these standards. And in addition, there's going to be an extended webinar dedicated to this package of standards, which is scheduled for the 20th of February 2023. So please register for that. And don't forget, you can get in touch with the experts at RSSB via our website using the customer portal. Again, Mike and Darren, thank you very much for joining me today, and to our listeners, thank you for listening this far, and until the next time, stay well and stay safe.